So this is another important question. The compound formed when alcoholic solution of ethylene dibromide is heated with granulated zinc. So what is taken is ethylene is ethylene dibromide. Ethylene dibromide is heated with zinc. Actually, this is alcoholic in alcohol medium. What will be the product formed? So this is ethylene bromide. CH2Br, CH2Br. So when it reacts with zinc in alcohol and is heated, what is formed will be ethylene, and the zinc bromide will be eliminated. Actually, the four options given for this question: option A, ethene; option B, ethine; option C, ethane; and option D, bromoethane. Bromoethane. Ethylene is ethene. Ethine means acetylene. Ethane, you know, it is CH3CH3 or C2H6. Bromoethane is CH3CH2Br. So ethylene is also called ethene. Ene means a double bond. Ine means triple bond. Ethine is acetylene. Ethylene is ethene. So ethane is a saturated hydrocarbon. Bromoethane, you know, one hydrogen from the ethane is replaced by bromine. See this problem. CH3, CH2, CH2OH. This is propanol, all propyl alcohol. This is heated at a temperature of 170 degrees centigrade in the presence of a concentrated sulfuric acid. A compound A is formed. When the compound A is chlorinated at 500 degrees centigrade, compound B is formed. Now, four options are given. What is compound A and what is compound B? Instead of looking at the options, we can directly solve this problem. See, CH3, CH2, CH2, OH in presence of concentrated sulfuric acid. See, sulfuric acid is a very powerful dehydrating agent. It will pull out water molecule. So if the water molecule has to be pulled out, one O has to leave and two hydrogens are to leave. So if you write this elimination, the compound formed will be CH3, CH, double bond CH2. An alkene is formed. So when CH3, CH, double bond CH2, at a high temperature, chlorination is done. So at very high temperatures, radical substitution will take place. radical substitution will take place. So radical substitution takes place here. CH2Cl, the double bond remains undisturbed. So if the reaction is carried out at low temperatures, what will happen? At ordinary temperatures, the 2 chlorine would have got substituted here, would have got added here. This is addition reaction at low temperatures. But at high temperatures, radical substitution takes place and this is formed. Actually, there is a resonance structure here. This can be like this: CH2, Cl, CH double bond CH2, or it can be on the other side, CH2 double bond CH, CH2 Cl. So like this, it can in a resonance form. So here what you have to understand is chlorination at ordinary temperatures will go ionic addition. Chlorination at the elevated temperatures will undergo radical substitution. So the compounds formed are, so this is A and this is B. This is B. An organic compound C6H12, let me call it X, on reduction gives C6H14, which is Y. Now X on ozonolysis gives 2 aldehydes. X on ozonolysis gives 2 aldehydes. 2 aldehydes. One is C2H4O and other one is C4H8O. This is 1 and this is 2. We have to identify what is X, what is Y, what is 1 and what is 2. First of all, what is X? C6H12 means its molecular formula is CnH2n. So that shows it is an alkene. So the first idea we are getting from the question is X is an alkene. Now on reduction it becomes a C6H14, which means it is CnH2n plus 2. It is an alkane. So an alkene is going to become an alkane. So the alkane with the 6 carbons can be easily identified. It is hexane, CH3, CH2, 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 CH3 hexane. Now the problem is, in alkene form, where was the double bond? So somewhere the double bond is there. What is the position of the double bond? Now you look at this. During ozonolysis, it is getting broken into 4 into 2. 2 carbon one side and 4 carbon on the other side. Therefore, the double bond might have existed somewhere here. Therefore, the X has to be CH3, CH, double bond, CH, CH2, CH2, CH3. Why? You do the ozonolysis reaction for this in the presence of ozone. CH3, CH, one O here, CH, CH2, CH2, CH3, and two O's are connected here. So this is ozonolysis. So now for the formaldehyde formation, so for the aldehyde formation by ozonolysis, one will get broken down like this, and the other one will get broken down like this. Therefore, the aldehydes are formed on this side acetaldehyde CH3 CHO according to the formula given C2H4O. So this is the compound 1. On the other side, it is butanaldehyde. It is butyraldehyde CH3 CH2 CH2 CHO. The molecular formula is C4H8O. So this is the compound 2. So it is very simple that we have identified this is alkane and this is alkene. But we had a problem to locate only the double bond. Even that double bond we could locate from the cleavage taken place during the ozonolysis. Therefore, we have identified all the 4 compounds. So compound X is this. That is 1,2,2-hexene. Compound Y is hexane. And the compound 1 is acetaldehyde. And 2 is butyraldehyde. So the investigation has been done and we have arrived at the answer. An alkene X is obtained by dehydration of alcohol, Y. X on ozonolysis. X on ozonolysis gives 2 molecules of ethanol. Ethanol means ethylaldehyde. Ethanol is IUPAC name. 2 molecules of ethanaldehyde. Ethanol. What are X and Y? Similarly, number 1, it is an alkene. It is formed by dehydration of alcohol Y. On ozonolysis, it gives 2 molecules of ethanol. Now look here, what is ethanol? Ethanol is a CH3 CHO. So it is giving 2 molecules of ethanol means certainly it is going to be an alkene with 4 carbons. As 2 ethanols are given, automatically it is understood that the double bond is present between 2 and 3, symmetrical. So C, 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 C. It has to be broken equally half. So double bond is here. So here is CH3, CH, CH, CH3. Only when such alkene is present. So look here, on ozonolysis, it will give CH3, CH, O, CH, O, O, then CH3. So this will break like this, and it will break like this to form an ethanol here and another ethanol here. So our finding is this is X, the alkene, which is obtained by the dehydration of alcohol. So what is the alcohol? Alcohol supposed to be CH3, CH2, CH, CH3, OH. So this OH and hydrogen from here will leave and form the 2-butene. If you put OH here or OH here, no problem. Both the same compound because it is 2-butanol. See, the 2-butanol can also be written as CH3CHOH, CH2CH3. This is also 2-butanol. So 2-butanol is Y, 2-butene is X. So on ozonolysis, they give 2 molecules of acetaldehyde. Find out the products for the following reactions. First reaction, CH3, CH, Br, CH2, CH3 in the presence of alcoholic KOH. Second reaction, CH3, CH, CH3, CH, double bond CH2 on ozonolysis gives Y plus Z. Here it is X. You have to identify what are X, Y, Z. See, alcoholic KOH, what is happening is beta elimination. So beta here, I've already told you, this is also beta and this is also beta. It is always this one is preferred because terminal alkenes are less stable. So the bromine and one of the hydrogens from this CH2 will leave, and what is formed is CH3, CH, double bond, CH, CH3. So this is X. In ozonolysis, you know how to write the ozonolysis: CH3, CH, CH3, CH, ozone is getting connected like this. So when the compound is getting broken, it breaks like this and this breaks like this. So the compounds formed by ozonolysis, this is CH3, CH, CH3, CHO. So this is an aldehyde. This side, formaldehyde is formed. Formaldehyde. This is 2-methyl propanol. 2-methyl propanol. 2-methyl propanol. This is methanol. IUPAC name methanol. So the compound Y is this, compound Z is this, and the compound X is this. Clear?